So in this video, I'm going to talk about arithmetic series. So I'm going to start off by explaining what an arithmetic series is. Then I'm going to explain the equations for the arithmetic series, how to use them, what they're for, what each of the terms mean. Then I'm going to explain to you how you can use the equations to calculate a term in the series. And then I'm going to talk about using one of the other equations to calculate the sum of the terms in the series. So first of all, what is an arithmetic series? So an arithmetic series is a collection of numbers which go up by the same amount each time. So for example, we can have 4, 7, 10, 13, 16. Right, and then that would continue. Now you can see there that I've got a series of numbers and every time it's gone up by the same amount. So every time it's gone up by 3. So from 4 to 7 has gone up 3, from 7 to 10 is up 3, from 10 to 13 is up 3, from 13 to 16 is up 3. The series, if it's an arithmetic series, it must always go up by the same amount. It doesn't matter what that amount is, but it must go up by the same amount, otherwise it's not an arithmetic series. So what I've got here is each term is going up by 3. Every time. So 3 is what's called the common difference. Okay, if a series doesn't have a common difference, then it's not an arithmetic series. So arithmetic series will always go up by the same amount each time. It will always have a common difference. Common difference doesn't have to be 3. Just in this example, it is 3. Now, there's a couple of equations that we can use. So equations are like that. Now that is the equation for working out the nth term. So I'm just going to label what some of these things are. So this here is the nth term. This is the first term. This n here, that's the number of terms. And then this d here is the common difference. Okay, so in the case of my sequence here, I would say that, so A would equal 4 because the first term is 4. My n, if I'm trying to work out, say I want to work out the 6th term, so if I was working out the 6th term, then n would be the number of terms, so n would be 6. We'll come back to that one in a minute. My first term, my common difference here, d, so d is the common difference. D is equal to 3. Now, if I want to say I want to find the sixth term. Okay, so if I want to find the 6th term, then I would need to work out U6. So I'd say that U6, because I'm working out the 6th term, and if I'm working out the 6th term, then n would equal to 6. So the 6th term would be equal to, and then it would be 4 plus, and then 6, take away 1, and then times the common difference, which would be 3. So my 6th term would equal 4 plus 5 times 3, which would equal 5 times 3 is 15 plus 4 is then 19. So what I'm saying there is that my 6th term would equal 19. If I go back to my series, I can see here, it starts off 4, goes to 7, to 10, to 13, to 16. The next term would be 19. I didn't mention here the number of the terms. So this is the first term, this is the second term, this is the third term, the fourth term, the fifth term. So that's my value for n. So if I worked out with U1, that would give me the first term, which would give me 4. If I worked out U2, that would be n is 2, the second term, that should give me the answer of 7. If I worked out U3, that would be the third term, and that would give me the answer of 10. Okay, so I can use the U equation to work out that. So if we just let's do another example. I'll extend my page down here a little bit. So let's say we have another sequence. So let's say we're going to start with 12, and then we're going to go to 18, 24, 30, 36. Okay, so we should be able to see here in this case that the first term, A, is 12. The common difference, D, is going to be 6, because each time it's gone up by 6. And say I want to work out the 10th term. Okay, if I want to find the 10th term, then I'm going to use U10 is equal to, so my n is going to be 10. And then I would say it would be A, which would be 12, plus, and then n take away 1, and then times the common difference, which is 6. So that would therefore be 12 plus 6 times 9, which is 54. So the answer should be 66. So in that case, my 10th term would be 66. So you could be able to continue that along. It's basically the 6 times table. So it would go 36, and then it would go 42, 48, 60, 48, 54, 60, 66. And the 10th term would indeed be 66. All right, if we continue on a little bit longer, then what I want to show you next is for finding the sum of the terms. Okay, so there's another equation here for that. Let's write that. What colour did I use last time? Blue. So the equation for finding the sum of the terms is to find the sum of the n terms. So again, it's the sum of however many terms you want, and it's equal to n divided by 2, and then a plus l. Okay, it's also equal to n divided by 2, 2a plus n minus 1 times d. Now in this case, the terms of the symbols are similar, so n is still the number of terms. A is still the first term. L this time is the last term. Okay, now what has happened here to actually get from the first equation, this one here, to the second equation, this one here, it's what I've done is substitute in for the L using the equation we had earlier. So using this equation for the nth term, use the A plus n minus 1 times d. So substituted that in place of the L there. So I've got an additional A, that's why it's now become 2A, because it was A plus n minus 1 times d, and then that's substitute that in. So if you don't know what the last term is, then you can stick that in there and you can work out what it would be regardless. So if we do an example here, so say we have another sequence. So say our sequence goes, let's use the same one we had the first time, 4, 7, 10, 13, 16. Okay, and say I want to find the sum of the first 4 terms. Okay, now in this case I could add that together fairly easily, so I'm just going to do that so we can see and see if we get the same answer. So the sum of the first 4 terms would be 4 plus 7 plus 10 plus 13. So that is equal to 23, 30, 34. Okay. Now we can also use it in the equation. So the sum of the first 4 terms should equal to n over 2, and then the first term, which is 4, and the last term, which is 13. So if we add those two together and then multiply that by n over 2. So n was 4. So I should have that 4 there. So that's going to equal then 2 times and then 17. So we can see that's 34. Now the reason this works is because in any sequence, this number plus this number is going to be the same as this number plus this number. All right, whenever you start from the ends of the sequence, you add the 2 last numbers in, and then if you go further back and further back and further back, every time you go in, the numbers are all going to be the same. So that's how the equation is derived. It's the first one plus the last one, and then multiply by how many there were, or half the number in between. So we can work it out there, and we can use the formula there. So that would explain how that would work. You can also, if you wanted to, use the other formula if you didn't know the last term was 14. So say we want to work out the sum of the first 25 terms. So say it says, find the sum of the first 25 terms, then in this case it would be more sensible to use the second version because we don't know what the 25th term is. So that would be n over 2, and then it would be 2a plus n minus 1 times d. So S25 would be 25 over 2 times 2 lots of a. So the first term is 4, so that would be 8. Plus, and then 25 take away 1 would be 24. And then times by the common difference, which would be 3. So then we can work out what that is. So use my calculator for that. So it's going to be 24 times 3, and then plus 8. So in the bracket is 80. And then we're going to multiply that by 25 and divide by 2. So divide by 2 first, and then times by 25. So that gives me 1,000. Okay, so by adding the first 25 terms together, the answer should be 1,000. Now, it would take me quite a long time if I actually wrote out the whole sequence, wrote out what all the numbers were, and then add them all together. So using the formula is much more sensible. And in this case, it's more sensible to use the formula because we don't know what the last term is. I guess we could work out what the 25th term was first and then put it back into the other formula, but that would also take a bit longer. All right, so that is how we use the arithmetic series formally and how an arithmetic series works. Thanks for watching.